Properties of exponents. So as a review, an exponent is the number that a base is raised to. So an exponent is the number that a base is raised to. So in this case, the base is a, and the exponent would be n, some number. And when we have exponents, that means that whatever that base is, it's going to be multiplied to itself the number of times that exponent is. So working with properties of exponent, if we have a base, then it's known to have an exponent of 1. So you will not see any exponents that have 1. So when you have a base, you need to know that there is an exponent of 1. So if you have a number, we know that that number 5 here is our base, that really it has an exponent of 1. So you're not going to see the exponent 1. You need to know that there is an exponent of 1. So when you're asked to simplify and you have a quantity raised to the 1 power, well, it's just simply whatever that quantity is, in this case, xy. So you can't leave something with the 1 power. In simplest form, that 1 power would go away. The zero property of exponents is this. Anything raised to the 0 power will equal 1. So the base here is a raised to the 0 power, it equals 1. So if you have a number and it's raised to the 0 power, it's simply 1. So 5 to the 0 power equals 1. If you have a quantity raised to the 0 power, that whole quantity is going to equal 1. So you have to be careful, because when 0 is mixed into a multiplication problem, a 0 exponent is mixed into a multiplication problem, the only part that equals 1 is the base that has the 0 power. So in this case, you end up having x to the 0 power, and it's multiplication because it's stuck together, times y squared. So x to the 0 power times y squared, you have to simplify. So in this case, we know that x to the 0 power equals 1, and we end up having 1 times y squared. So to simplify, in this case, we would just end up with y squared. So remember, anything raised to the 0 power equals 1, and when something's attached to it, it means that it's being multiplied by 1. And when you multiply by 1, it just simply equals whatever you're multiplying with. Pause and try. So I hope you got here that the answer is 2, because you end up having x to the 0 power equals 1, and 2 times 1 is going to end up being 2. Pause and try. So now here, because the parentheses is wrapped around the whole quantity and it's raised to the 0 power on the outside, we're going to end up with the whole thing simply equaling 1. So the first property that we're going to work with here is the multiplication property. And how the multiplication property works is if you have like bases, so my bases here are a, the base times a base. If we have like bases, when we're multiplying, you simply just add the exponents. So in this case, when I have a to the n power times a to the n power, to simplify, I end up having a to the m plus n power. So usually we're going to see this in operations with numbers and like bases. Now in this case, you have to be careful because the base is a number. So we have numbers here, 2 to the 4th power times 2 to the 3rd power. So instinctually, you might think that you want to multiply the 2 times 2 first, but order of operations says you cannot do that. Exponents always come before order of operations. So when you have like bases with exponents, to simplify, the first thing you're going to do is add the exponents. So in this case, you end up having 2 to the 7th power. 4 plus 3 equals 7, and that's going to be the exponent for 2. And then you could simplify if you have a calculator or you want to manually do this. So notice here, I mixed in the property of the 1 power. because whenever you have a base, we do have a power, and we're not going to see that power when it's simply 1. So notice here I have z to the 6th power times z. So when I do the multiplication here, I'm going to end up having z to the 7th power because that z really has an exponent of 1. So you have to either see it or write it so that you don't forget to add the exponents together. Pause and try. So in this case, you have like bases. That like base is 3. So you're just going to add the exponents. You get 2 plus 3 is 5. So it's going to be 3 to the 5th power. Pause and try. So remember that that exponent for that x is a 1. So when you multiply here to simplify, you're going to end up with x to the 9th power. So now I want to show this property, how you're going to see it. Multiplication of monomials, or one term times another term. So I know it's multiplication because it is attached to each other with parentheses. So it's multiplication. Now, keep in mind, multiplication is multiplication. So the numbers here, the 3 and the 7, are being multiplied together. It's 3 times 7. And then we have the like bases. And the like bases are that k. We have k to the 5th and k to the 3rd. So now you want to make sure you multiply the numbers. So 3 times 7 is going to be 21. And then for the like bases with exponents, you want to make sure you add the exponents together to simplify. So this will multiply to 21k to the 8th power. So this next one, I want you to notice I have numbers and I also have multiple variables. So be careful when you have a lot going on that you don't forget. Numbers get multiplied. I'm not taking 12 and adding it to 2. This is multiplication. So this is going to be 12 times 2. And then you have x squared times x. They're the like bases. And then you want to make sure you put it in simplest form by following the rules. So 2 times 12 is going to be 24. X to the 3rd power, because that x really has an exponent of 1. So it's 2 plus 1, which is going to give us 3. And then y to the 5th power. Pause and try. So in this case, you have a negative times a positive, so you're going to end up with a negative 8x to the 6th power. Pause and try. So even though we have multiplication here, and you see that the second parentheses has a 3 in front, we always have to have the number in front of the answer. It's called a coefficient, so it needs to go in front of the answer. So really you have 1 times 3, which is simply going to be 3, and then you're going to end up with x to the 8th times x squared is going to give you x to the 10th power, y to the 2nd power, y to the 6th power will give you y to the 8th power. So the next property is division property. So division property works the opposite of multiplication. Instead of adding exponents, you subtract exponents. Now you want to subtract and leave it in the position where the higher exponent is, because you don't want negative powers. So if you subtract the top from the bottom and the bottom has a higher number, you're going to end up with a negative power. So how I always do this is I look at the division problem, I see where the higher power is, and I subtract the exponents and leave the base where the higher power would be. So in this case, if you have a to the m power over a to the n, and m is larger, you're going to subtract and you're going to end up with a to some power. But if n is larger, you're going to have to subtract the n from the n, and it's going to stay in the bottom, or you're going to end up with a fraction. So in order to do this, you have to be careful, because if you don't have the 1 up top, then you won't have the fraction that the answer would be. So if nothing is left up top, make sure you place a 1 up there. So here's an example. We have x to the 5th over x to the 3rd. The first thing I'm saying is, where's the higher exponent? Well, the higher exponent's up top, so I'm going to subtract, and I'm going to leave it up top. So we end up with x to the second power. This next example, I want you to notice here that the higher exponent's on the bottom. So I'm going to need to subtract the 5 from the 8, but I'm going to subtract it, leaving the variable on the bottom. And because nothing's going to be left up top, I need to put that 1. So I end up having 1 over y to the third. Now notice this next example. We have z to the 5th over z to the 5th. Well, this is an example where if you have the same thing over the same thing, it equals 1, right? If we had 3 over 3, it would equal 1. So whenever we have the same thing over the same thing, it's going to equal 1. But I want you to understand now where that 0 power comes from. Because in the division problem, if we were to subtract here, we would end up having z to the 0 power, and anything to the 0 power equals 1. So that's kind of a mini proof of where that 0 power comes from. Pause and try. So you're going to end up here with x to the 4th, because remember the x on the bottom has a power of 1. The higher exponent's on top. You're going to subtract, and you're going to leave it up top. Pause and try. So you see here we end up having the higher exponent on the bottom. So you're going to subtract, and nothing will be left up top. So you end up with 1 on top, and you get z to the 6th on the bottom. Pause and try. So notice here our bases are numbers, but it works the same way. Properties of exponents work the same way with numbers. Variables are numbers. We just don't know what the number is yet. Eventually you will solve for that number. But when you have bases that are the same, even when they're the same number, you use the property of exponents to simplify. So in this case, you end up having the higher exponent on top. When you subtract here, you end up having 7 minus 6 is going to be a 1, and you can't leave that exponent a 1. So your answer would simply be 15. So now I'm going to show you a problem that has a multi-step properties of exponents for division. So whenever I see a problem like this, I want to see it as 3 separate problems, like bases grouped together. So you have to be careful here. So when you're doing this problem, I always like to start off with writing a line, that division line, and then I do it like a puzzle, placing piece by piece where it belongs. So I look at the first piece of this puzzle, and I'm saying to myself, it's 5 over 15. This is a fraction. Fractions need to be reduced. You're not subtracting 5 from 15. You need to reduce this fraction. So when you reduce a fraction, remember you're dividing out their common factors. So in this case, 5 goes into 5 once, and 5 goes into 15 3 times. So you simplify fractions. You don't subtract them, you simplify. So we end up having 1/3 for the first piece of this puzzle. I go to the next piece, and I'm looking, and I see that x to the 5th is the highest power, so I need to subtract the 2 from the 5, and it's going to be placed on the bottom here. So we end up having x to the 3rd on the bottom. And then I look at this last piece. We have y to the 7th over y. Remember that y really has an exponent of 1. So the higher exponent's on top, so I need to subtract. So I'm going to end up having y to the 6th, and I'm going to place that on the top of the line. So now I have my problem in simplest form. So I want to be clear here. We can't leave that 1 on top because it's like a coefficient. And you can't have a coefficient of 1 in a simplified problem. So when you end up with a 1 up top and there's something else up top, you need to take the 1 away. So you end up having y to the 6th all over 3x to the 3rd. Pause and try. I like to write that line and do piece by piece. So I'm looking at that 3/9, and that's just reducing a fraction. So I end up with 1/3. Then I look at the next piece, the higher exponent's on top. I subtract, and it's going to stay on top. So I end up with x, because remember, you get x to the 1 power, and you can't leave the 1 as an exponent. And then I move to the next piece, and I see that the higher exponent's on the bottom. So I'm going to subtract, and it's going to stay on the bottom. So I end up with y squared on the bottom. And then you're just looking here and you're saying, oh, I got that coefficient of 1. So when I simplify this, I want to make sure that I don't leave that 1 with the x. So your final answer here would be x over 3y squared. Pause and try. So now when you're looking at this one, I'm drawing my line because that's what I do. I'm looking at this piece and I say, okay, well, I have 8 over 2. Well, that's division. 8 over 2, well, 2 divides into 8. So I'm going to end up with 4 on top, a whole number. And then I look at this next piece. I'm looking at the x fifth over x to the 4th, right? Well, when the higher exponent's on top, so you're going to subtract, and it's going to stay on top, and you end up with x to the 1 power, and you can't leave that 1 power, so it's just simply x. Now, what happens to that y to the 0 power? Well, whenever you have something to the 0 power, we know that that equals 1, and the whole thing is being multiplied because it's all attached. So anything times 1 is simply itself. So we're going to end up simply having 4x as my answer. So I don't need the line because nothing fell below, nothing fell in the division position. So my whole answer here would end up being 4x. This next property is called the power to a power property. And how this works is you have a quantity inside parentheses that has a power in it. And then there's a power on the outside. Well, to simplify this, you need to take the two powers and multiply them together. So we end up having a to the m times n. The base is a, the powers get multiplied. Okay? So in this case, we have w to the 6th power, and then it's all raised to the 4th power. So we see here, to simplify, I'm just going to take the 6 times 4, multiply together, and give the w to the 24th power. So a power to a power, you multiply the powers together. So what's going to happen here? We have s to the 0 power, and then it's raised to the 4th power. Well, because the power to a power property says multiply the powers together, and you're going to end up with 0 times 4, well, 0 times 4 is 0. And anything raised to the 0 power equals 1. So you want to make sure that you're doing the properties and also keeping in mind the different definitions here. So anything raised to the 0 power is going to equal 1. Even if you said, okay, well, s to the 0 power is 1, 1 to the 4th power, well, 1 to the 4th power is going to be 1. Because 1 times 1 times 1 times 1 is 1. Pause and try. So here you end up getting 5 to the 15th power. Pause and try. Here you end up getting x to the 18th power. Next property is power of a product property. And the product means I have two things being multiplied together. In here, in this parentheses, I have two things being multiplied together, and I have a power on the outside. And notice that the variables are different. So they're different variables for this property, because if they're the same, you would just multiply them together. So in this case, when you have a power of a product property, you need to take that power and give it to everything inside. So you end up with a to the m power and b to the m power. In this case, you see we have a quantity xy raised to the 2nd power. Well, you have to simplify. It has to be in simplest form. So you can't leave it in parentheses. So to simplify, you're going to take that power on the outside and give it to everything inside. So you end up with x squared times y squared. Now notice here that I have a number instead of just variables. But I need you to understand this is the power of the product rule. The product here is 2 times x. So everything inside needs to get that power. And keep in mind, it's a power. I'm not taking 2 and multiplying it to 3. I'm taking 2 and I'm raising it to the 3rd power. Make sure you take the power and give it to the number. And that number now is going to be multiplied to itself the number of times that power is. So you're going to have to simplify that piece. And then you give the power to the variable, so you end up with x to the 3rd. But lastly, if you have 2 to the 3rd power, you need to make sure you multiply that out. 2 times 2 times 2. That's going to equal 8. So you have to be very careful not to confuse that it's multiplication. When we're dealing with power to a power or power to a product, you're taking that power and giving it to the number. And you need to make sure you multiply that number to itself the number of times that exponent is. So be careful with this property in numbers. Pause and try. So notice here you end up getting 10 to the 2nd power. It's not 10 times 2. It's 10 to the 2nd power. So you end up with 100y squared. Pause and try. So you're going to end up having 25x squared, y squared. So this next example is just a combination of the power to a power and the power to a product. So it's a combination of the 2 properties in one problem. So notice here I have a product inside. A product is things getting multiplied together. And then those variables also have exponents. And then on the outside of the parentheses, I have an exponent. So that gives me that power to a power property. So I still have to take the power on the outside of the parentheses and give it to everything inside. And because they have powers, when I give it, I need to multiply those 2 powers together. So I'm going to end up having x to the 4th power times y to the 12th. So it's really important that you give it to everything inside by multiplying the powers together. So notice this next example, because you got 2 properties going on, and now I mixed in a number. So you have to be careful when numbers are mixed in and there's an exponent on the outside of parentheses, because that exponent needs to go to the number as an exponent. That number needs to be multiplied to itself the number of times that exponent is. You're not taking the exponent and multiplying it to the number. You need to raise the number to that power. So you end up having 3 to the 2nd power, x to the 10th, y squared, z to the 6th. And then you want to make sure you do the multiplication of 3 to the 2nd power, which equals 9. Pause and try. So here you have 3 to the 3rd power, x to the 15th, y to the 12th, and make sure you simplify that 3 to the 3rd. It's 3 times 3 times 3, which equals 27. So this next property is the quotient raised to a power property. So a quotient means that I have a fraction, okay? And it's a fraction that I can't simplify because they're different bases. So you're going to take the power on the outside and you're going to give it to everything inside, the top and the bottom. So when you have a quotient, you're going to have a fraction, and if it's raised to a power, you need to make sure you give that power to everything inside. So in this case, we have x over y, and we have to the 5th power. To simplify or to remove the parentheses, I need to take that power on the outside and give it to everything inside. Now notice here, I mixed in that property of power to a power with the quotient property. So it works the same way. I still have to take that power on the outside and give it to everything inside. But because inside has powers, I need to multiply those powers together. So I end up having r to the 16th over s to the 10th. Pause and try. So you want to be careful here. You end up with a to the 15th over 27 because you have 3 to the 3rd power. 3 times 3 times 3. And then you have b to the 6th power.